Welcome to Study Loop.
Okay, we've got essentially what are three acids. We've got DOPA, right, where the entire molecule is as follows. Which is really telling us that we have a carboxylic acid, because this carboxylic acid is the strongest acidic group on DOPA, right? Similarly, when we have aspirin here, note that COOH is just another way of drawing a carboxylic acid, but we also have an ester. Okay, this is aspirin. And Ritalin. Which we'll note does not contain a carboxylic acid, right? In fact, the most labile proton is on this amine here, right? And so the question is saying if we react these with dilute sodium hydroxide, for which molecules will there be an acid-base reaction? We'll note that sodium hydroxide is a rather strong base, and carboxylic acids are borderline strong acids. They're not technically strong acids, but they have very low pKa's. So low pKa, low pKa. And we're talking pKa's, more around 7, right? Or lower, depending, right? In contrast, in terms of Ritalin, this amine that's pKa that's closer to, say, 40, which is, 10 to the 30 times less acidic than either of these carboxylic acids. And that is that sodium hydroxide is not a strong enough base to deprotonate something with a pKa of 40. Not strong enough to deprotonate an amine, right? So therefore, we should only expect the acid-base reactions will be occurring with DOPA and aspirin only, right? Because Ritalin does not have an acid which is strong enough to interact with sodium hydroxide.